Hello guys, welcome back to another video. Today we'll be doing this grade 11 mathematics control test 2022. So we'll be starting with question 1. Here is it. Here we have question 1, and then we're going to start with 1.1. Then from 1.1 we'll go to 1.2. So those are the two questions that we will be doing. The total is 20 marks. This is patterns. You need this for your June exam. So I thought let's start tackling them because they are quite easy to do. So we have linear and quadratic number patterns, which is what grade 11s need. So without wasting any time, let's get into the video. And please know that I will not be showing this question paper on screen, as I will just only be answering the questions. So if you have to write it somewhere, please do, so that you can follow along. Now, without wasting any more time, let's get into the video. Okay guys, here we have our first. This is question 1 on that 2022 June common test. We are still busy with patterns for grade 11. So we're going to be answering this question. So let's do. Whenever you are told that you are given a linear or a geometric pattern, you must know that the first difference is constant, unlike the quadratic number pattern where the second difference is constant. So here, when you say term 2 minus, this is term 2 minus term 1 will give you 6. Here, term 3 minus term 2 will also give you 6. Term 4 minus term 3 will also give you 6. So this is how you will know that this question is linear, when the first difference is constant. So 1.1.1, we are told to determine the nth term. So the nth term is like this: Tn equals to a plus n minus 1 d. So this is the formula for the nth term. Now a represents the first number in the pattern, and d represents the constant difference, which is 6 in this instant. So what do? We are going to substitute what we have. A is 11 plus n minus 1, and then the constant difference of 6. Now this is also for linear patterns are grade 10's patterns. So if you are grade 10 and you are watching, this will be quite helpful for you as well. So now we have 11, right? That is 11 plus this 6 multiplies the bracket. So we're going to 6 times n, that is 6n. And then we have 6 times negative 1, that will be negative 6. So here we have Tn equals to 11 minus 6, which is 5. So we write it in this manner: 6n plus 5. This is the formula for the nth term. And then 1.1.2 says to us, what number is term 20? So they've given us the term. They say we should find what is the number that represents term number 20. So n represents the number of the term, right? If you want to see whether this answer is correct, you can substitute any of these numbers on the pattern in the place of n, and you will see you can say 6, and then in n replace it with maybe let's say 2. Say 6 times 2 plus 5, right? So how much is 6 times 2? Is 12, and then plus 5, 13, 14, 15, 16, 17. So it's 5. Or you can also replace this by 4 or whatever, just to see that you have got it right. That's how you check if your answer is correct. Now we are asked to check which number is term 20. That's 1.1.2. So what we do, we just say, is this T20 equals to 6n plus 5, which is T20 equals to 620 plus 5. And then T, which is 1020, equals to 125. There you have it. Now we have 1.1.3. 1.1.3 says, which term is 299? How many terms do we have in this pattern? Now they told you this is the last number in this pattern. And now we want to know how many terms do we have? So that is n. And you are given this represent Tn. So Tn is represented by this 11 is Tn, this 17 is Tn, this 22 is Tn. So we have 299, which means we have the Tn, right? Tn equals to 6n plus 5. So we have 299 equals to 6n plus 5. We don't know the value of n, so we say 299 minus 5 equals to 6n, right? Because we want n by itself. So 299 minus 5 will give us 294 equals to 6n, right? And then we'll just divide both sides by 6, and then n equals to 49, which means we have 49 terms in here, in this pattern. So 1.1.4 says we have a quadratic pattern, right? So in this oh, sorry for that, it was not showing that side, sorry about that. So we have here we have the last question, which is 1.1.4. Here is that 1.1.4. It says the terms of this linear pattern is the sequence of first difference of a quadratic number pattern, which means the 11, 17, 23, 29, etc. is the first difference of a quadratic pattern. You know, right, that a quadratic pattern has a second constant difference. So here was the first difference, which is not constant when you are dealing with quadratics. So this pattern is derived from a second difference of an original quadratic pattern. This is what they say here. And the first difference of the quadratic pattern are 11, 17, 23, and so on, as you can see this pattern. And if the fifth term of this quadratic pattern is 100, what will be the value of the second term? So if the fifth term of this quadratic pattern is 100, what will be the value of the second term. Now let's answer that quickly. Okay, let's answer that. 1.1.4. Now we have term 1. We don't know what is term 1. And then we have term 2 here, term 3, term 4, and then we were told that term 5 is 100, right? So the difference between these terms is that pattern that we originally had, which is 11, 70, 23, and 29. Now can you see that for us to get here, we'll say 100 minus 29 will give us the term 4. But here we are looking for term 2. So which means we're looking for this one. So which means term 2 will equals this 100 minus 29 minus this minus plus this 23 and plus this 17. So that will be 31. We're not including this because when we minus this one, we'll be getting term 1. So is this 100 minus this is this minus this is this minus this is this. Or you can just do it in this manner that I have done it. That concludes question 1.1.4. I hope you guys enjoyed it. Thank you very much for tuning in. I will be doing question 1.2. Yeah, I'll be doing question 1.2. Now we are going to do 1.2. That is the question that we will be doing now to conclude this question. This is a quadratic pattern. You can write down the questions, because the first one says write down the next two terms in the pattern. The second one says determine the nth, the general term of this pattern in the form Tn is equals to an squared plus bn plus c. And then 1.2.3 shows that all the terms of this number pattern are even numbers. And then it says a new pattern with a general term Pn is formed such that Pn equals to Tn minus 128. How many negative terms will there be in this new pattern? Now let's solve this one as well. Okay guys, now let's go to 1.2. So in this pattern we have the following: negative 16, negative 12, negative 4, and we have 8. So on the first question, we are asked to give 1.1.2 and 1.2.1. We are asked to give the first, the second, the two next terms, right? So what we are going to do is that you say 12 minus 16, which will give us 4, sorry, and then you say negative 4 minus negative 12, and that will give us 8, and then we'll say 8 minus negative 4, and that will give us 12. And then the third constant difference will be 4. Let me do it so that you can see it. So negative 12 minus negative 16, that will give us 4. Then 4 minus this one will give us 8. This will give us 12. So the difference here is 4 and this one is 4. So we can actually get the two next term. So what we are going to do to get the two next terms is that we can say this increases by 4. So 12 plus 4, that is 16. This is 4 here. And then here we'll have 20, right? Then you will have 20. Now the difference is 4 for everything. Now what we are going to do in this instant is that we are going to say 8 plus 16 will give us the next term, which is 24. Because when you say 24 minus 16, it's 8. Then we say 24 plus 20, that will give us 44. So 1.1.2 is 24 and 44. 1.2.1, 1.2.2. So yes, that is how we get those next terms. Now here, what is required, now we have to do 2.2.2. Now here they want us to determine the formula of the nth term in a way that they have given us. So we need to express that. What we are going to do here, this is how you determine. You have to get A, B, and C, right? So this is the way that you are going to do it. On this thing that you have done here to determine the third difference, you are just going to say 3A, not 3, sorry, 2A equals to 4. Then here you say 3A plus B equals to 4. Then here you said A plus B plus C equals to negative 16. That's how you do it. And then the first thing we are going to do is solve for A. Now A, we are given as 2A equals to 4. For solve for this A, we divide by 2. Then our A equals to 2, right? So here we are trying to find B. We'll say 3A plus B equals to 4. So it's 3. We substitute this A here plus B equals to 4, right? This is going to be 6. So we say B, this 6 will go that side, will equals to 4 minus 6. So our B equals to negative 2. So we have A and we have B. Now let's find C. As we have said here that A plus B plus C equals to negative 60. This is how we're going to solve it. A plus B plus C equals to negative 60. Now you will substitute whatever you have. We have 2 plus negative 2 plus C equals to negative 16. 2 plus negative 2 is 0. So C equals to negative 16. Can you see? You have A, you have B, you have C. Now we can express this the way it was required for us to do in the question. So we will say Tn equals to 2n squared minus 2n minus 16. And we have done 1.2. We have determined the nth term. 1.2.3 says we have to prove that all the number in this sequence will be even numbers. So as you know that all even numbers are natural numbers. So we can say Tn is equals to 2n squared minus Tn minus 16. So here, nature of roots will be working. So you reference to the nature of roots. So this is common, and then you can have n squared minus n minus 8. So you can multiply this bracket with the 2 and still got that. So n is a natural number. So, and all natural numbers are even numbers, right? So because n is a real number, this bracket will also be a real number. So I hope you were taught nature of the roots. Nature of roots at school. This question will make clear sense of natural numbers and so on, because it has to satisfy 4 equals to that quadratic formula. Thank you very much, guys, for watching. Please come back. I'll be doing another patterns question, a different one from this one, quite a complicated and challenging one, just to make sure that we are on par and we know our work. Thank you very much for watching. Until next time.